Good morning, students. Today we will discuss the topic observability. Observability. Same as controllability, observability can also be discussed or explained with the diagram like this. Here we have integrator x2 dot. From here we have a feedback -1 minus plus. Here we have input u. Here we have another summing point, and this input is same u. Here another integrator, there state x1 dot, and here state x1, and this is our output. From this point we have a feedback of -2 minus or plus simply, right? Look, in the previous diagram, in controllabilities diagram, what we see in the diagram of controllability in the last lecture, we see that here input has no control over this state, right? But here input is connected with this state as well as with this state. Means input has control over the two states, therefore the system is controllable. But in this case, output is dependent on this state and this state, right? Output is dependent on both the states. Without calculating this state, we cannot find y here, but here output is dependent only on x1. Means output cannot be determined with this state, right? Output cannot be determined with this state, or this state's output cannot be observed. Therefore the system is unobservable. The method of determining the state of a system by observing its output concerns observability. The method of determining the state of a system by observing its output concerns observability. Right? In this case, we have state model as x1 dot is equal to -2x1 plus u, and x2 dot is equal to -x2 plus u. Input has control over the two states. And what is the y? Y is only x1. Y is only x1. So the output here, output is dependent only on x1. It means the x1 state can be observed with the output y, but x2 cannot be observed from the output y. Okay? So a system is said to be unobservable. A system is said to be observable, unobservable if, sorry, said to be observable if every state variable affects the output. If every state variable affects the output, then only the system is said to be observable. Right? We have a state model like x dot is equal to ax plus bu and y is equal to cx. In this case, if we find out state y naught, which is equal to c x naught, right, y1 is equal to c x1, which is equal to c a x naught, y2 ca square x naught, right? So like this we can find out y n minus 1 as c a raised to n minus 1 x naught, and from here we have in the matrix form, as we can write it in matrix form as y naught y1 up to yn minus 1, which is equal to c ca square and up to ca n minus 1 x naught, or x naught is equal to c ca square up to ca n minus 1 inverse y naught y1 up to yn minus 1. And for unique determination of state x naught, the matrix V or this matrix should have rank n. This matrix should have rank n. Right? It means for observability, this matrix should be non-singular. Right? And Kalman named this matrix as V and transposed this matrix as C T A T C T A T square C T up to A T n minus 1 C T as observability test matrix. And if this matrix V, observability test matrix V, is not equal, means determinant of this matrix V is not equal to 0, or its rank is equal to n, the system is said to be observable, right? For example, we have x1 dot is equal to x2, x2 dot is equal to minus 2 x1 minus 3 x2 plus u, y is equal to x1 plus x2, then the matrix A will be 0 1 minus 2 minus 3, matrix B will be 0 1, matrix C will be 1 1. We have to test whether the system is observable or not. Whether the system is observable or not. So for observability, we find matrix V as CT, AT, CT. So what will be AT matrix? Transpose this matrix 0 1 minus 2 minus 3. And what will be the CT matrix? CT will be 1 1, right? So V matrix will be 1 1, and here ATCT. So multiply this and this, we will have 0, and here minus 2, and here 1 plus minus 3, so minus 2. And determinant of V shows it's 0, so system is unobservable, right? So let's take one more example from the observability. We have x1 dot is equal to minus 2x1 plus x2 plus u, x2 dot is equal to minus 2x2 plus u, y is equal to x1 plus x2. So we will have matrix A is equal to minus 2 1 0 minus 2, B will be 1 1, C will be 1 1, so CT will be 1 1, AT will be minus 2 1 0 minus 2. We have to test the controllability and observability of the system both. So first of all, we'll check the observability. V is equal to CT 1 1 ATCT. So this multiplied by this, here we will have minus 2, and here we will have 1 minus 2 means minus 1. And obviously its determinant is not equal to 0. Therefore, the system is observable. And for controllability, we will check matrix U, which is B 1 1 and AB. Multiply this, minus 2 plus 1 minus 1. Here 0 minus 2 again is not equal to 0. So the system is controllable also. The system is controllable as well as observable, right? So this is it for controllability and observability. In next lecture, we will do some more examples related to controllability, observability, and transfer function, right? Thank you.